Okay, guys, for vectors, if you remember, we have actually to set, we have some physical quantities that's a scalar quantities, and some other quantities that's a vector quantity. For example, displacement is a vector quantity. So if I start from that point, and I'm going to call this is my origin, this is the origin of that room. If I move 3 steps to your right, if I move 3 meters to your right, can we describe that displacement? Yes, it's 3 meters to the right. So if I go back to the origin and I move 3 meters to the left, your left, can we describe that displacement? Yes, it's 3 meters to the left. But sometimes if someone change orientation, if you sit like this, your left and my left is gonna be the same, and your left and your colleague left is not going to be the same. That's why we have to choose what we call the coordinate system. So I'm going to say that if this is the origin, if I move in that direction, I'm going to call that positive. If I move in that direction, I'm going to call that negative. So any vector, not only displacement, can be a positive quantity or a negative quantity. And positive or negative means mainly direction. It does not mean anything but direction. So now if I move 3 meters in that direction, can we describe that displacement? Yes, it's positive 3, plus 3, positive 3. If I go back to the origin, and if I move 3 meters to the left, your left, can we describe that displacement? Yes, it's a negative 3. So the motion along one dimension can have a positive, it can be a positive quantity or a negative quantity, and positive or negative mainly means direction, nothing more. It's only direction. So position of an object can be positive, it can be negative, and that mainly means only direction. How about velocity? Look at this. This is what I call it a Cartesian coordinate system. We have actually two coordinate systems that we're going to use in this semester. The first one is the Cartesian coordinate system. I have to choose an x-axis and a y-axis and an origin. Those are the 3 quantities that we need to specify before solving any problem. Where is the origin? What is the x-axis? What is the y-axis? And divide them into units, measures, to be able to get a quantified answer for displacement, for example. So I'm going to say this represents us 1 meter, 2, 3, 4, and so on. And this is my x-axis. This is the x-axis. This is the y-axis. Each square represents 1 meter. Now, if I want to describe the point P, how can we describe the point P? It's, as you see, 5 along the x-axis, 5 units along the x-axis, and 3 units along the p-axis. The y-axis. That's why we say it's 5 and 3. How about that point, Q? We moved 3 units to the left, which is 3 units to the negative x-axis, and we moved up 4 points. That's why we call that point -3 and 4. Guys, can you describe that point? 3. So x equal to 3 and almost 8. So it's 3 and 8. So this point is 3 and 8. Usually the x coordinate comes first, then the y. That's why we say that point up there, that's 3 and 8. And we call that system a Cartesian coordinate system. So if I need to describe the point x and y, that point x and y, it's simply 3 units along the x-axis and 8 units along the y-axis. Can we describe it in a different way? Yes, we can describe that point, x and y point that we have seen a minute ago, using a polar coordinate system. And the polar coordinate system, it's mainly describe how long is that line that connects between the point and the origin. How long is it? It is. And the angle that line makes with the positive x-axis. So it describes the length of that line and the angle that vector makes with the positive x-axis, that angle. That's easy. I'm going to draw that on the board, and I will try to relate the two coordinate systems together. If I give you information for a vector on one system, coordinate system, you can easily transfer it to the other system. Okay. So on the board, this is my coordinate system. X, Y, and that's 0. And this is the vector R. That's how we write the vector. That's the vector, and an arrow on top of it means that arrow means that this is a vector. Okay, the projection of that vector R on the x-axis. If you draw a perpendicular to the x-axis in here, we call that part, that's the projection of R on the x-axis, or that's Rx. In the book or in the slide, sometimes you see me writing it as X as well. This is okay, this is okay, but this is X. This is the length of the projection of R on the x-axis. And this is the projection of R on the y-axis. That angle is 90. This is Y or RY. You call it Y or RY, whatever you want. So now we know that this is X, this is Y, and this is R. That angle, that's the angle theta. Guys, what is sine of the angle theta? What is sine theta? Okay. This is the same thing, this is Y. So you guys, you're saying sine theta, it's Y over R. Right? Yeah. Good. What is cosine theta? X over R. So if we know X and Y and R, okay, we can easily get the angle theta. Okay, look at this. Remember, in the Cartesian coordinate system, we deal with X and Y. In the Cartesian coordinate system, the system that I just showed you a minute ago, we deal with X and Y. With the polar, we deal with R and theta. R, how long is the vector, and the angle theta. Look at this equation. Y equal to R sine theta. X equal to R cosine theta. If we know R and theta, if we know information about the vector in the polar coordinate system, that means if we know R and theta, we can get Y and X. So we can transform from a polar coordinate system to Cartesian coordinate system if we know that information in the polar coordinate system. So if we know what is R, what is theta, I can get that point up there, which is X and Y. X will equal to R cosine theta, and Y will equal to R sine theta. Okay? Okay, guys? Okay, good. That's one. So now we can transform from polar to Cartesian. Can we transform from Cartesian to polar coordinate system? Let's see. I'm going to square Y, I'm going to square X and add them together. I'm going to square Y, and I'm going to square X, and I will add them together. So it's going to be R squared plus, so times sine square theta plus R squared times cosine square theta. Right? Right, guys? Can I take r squared as a common factor? I end up having sine squared theta plus cosine squared theta. And we know that sine squared theta and cosine squared theta, this equals to 1. So r squared times 1, that ends up giving us x squared plus y squared will equal to r squared. Now, if we know x and y, we can find r. So if we know the information about the vector in the Cartesian coordinate system, we can find the length of the vector, the magnitude of the vector in the polar coordinate system. Can we find theta? If we know x and y, can we find theta? Back to those two equations. I'm going to divide them. So y over x equal to y divided by x. It's going to be r sine theta divided by r cosine theta. That means r will cancel out. Then that means that sine theta over cosine theta, tan theta equal to y over x. So if we know y and x, we can find the tangent of the angle theta. And if we know the tangent of the angle theta, we can simply say that theta equal to inverse tan for y over x. Again, this equation and this equation, they tell us that if we know y and x, we can find r and theta. So now, simply we can transfer from one system, from one coordinate system to another coordinate system. We can go from polar to Cartesian and from Cartesian to polar. That's not a big deal. That's straightforward. Of course, do not memorize those equations. Guys, if you just draw this, you can simply come up with those equations, even if you forget them. Okay. And that's what I just showed you. Guys, theta, it's arctan or inverse tan for y over x, and r squared equal to x squared plus y squared, or r equal to square root of x squared plus y squared. This is how to go from Cartesian coordinate system to polar coordinate system. And from polar to Cartesian, if we know r and theta, yx will equal to r cosine theta and y will equal to r sine theta. Remember, theta is the angle between the positive x-axis and the vector. This is very important. It's the angle between the positive x-axis and the vector. Someone will say, if I choose this to be my angle theta, the angle between the y-axis in here and the vector, can we still transform from a polar to a Cartesian coordinate system? Yes. But in that case, y will equal to r cosine theta, and x will equal to r sine theta. If the angle theta is the angle between the y-axis and the vector, if that's the angle theta, and this is y, this is r, this is x, in that case, if you choose this to be your angle theta, then y will equal to r cosine theta, and x will equal to r sine theta. It's not a big deal. But usually, we define the angle theta by the angle between the positive x-axis and the vector. So this is going to be x according to the definition, and this is going to be the y. But if you reverse it, that's okay. As long as you know what are you doing, that's okay. Okay. Let's take that example. Look in here, we have a point that's 3.5, negative 3.5, and negative 2.5. If I look at, if you tell me that point, even if I don't draw it, I will know that this point is going to be located at the third quadrant. We call that the first quadrant, the second quadrant, the third, and the fourth. The first quadrant, x and y has to be, they have to be negative. Yes, it has to be, they have to be negative. Guys, who's right? Are they right or am I right? Are you sure? Yes. Are you sure? Yes. Are you sure? Good. Good. Yes, of course they're right. If you look at any point in here, x has to be positive and y has to be positive. Any point in this quadrant, if you look at it, that point, for example, x equal to 2 and y equal to 2. That point in here, that point, x equal to 0 and y equal to 3. Correct? So any point in this quadrant has to be x and y, they have to be positive. How about that quadrant? X negative, perfect, and y is positive. How about that quadrant? Both are negative. How about this one? X positive and y negative. Okay? Now we need to find the polar coordinates for that point. The polar coordinates for that point. In other words, we need, are you checking the stock market? Okay, good. In other words, we need to find r, how long is that vector r, and we need to find the angle theta. Can you remind me by the definition of the angle theta? It's the angle that's measured from the positive x-axis going counterclockwise till the vector. It's the angle measured from the positive x-axis and you should go counterclockwise till you reach the vector. This is the angle theta. Okay, let's do that together. This is a little bit tricky. It looks easy, but most of the students make a mistake in that part. In the exam, most of you guys, you make a mistake in here. So you have to pay an extra attention how to calculate the angle theta. Let me finish and I'll take your question. R is easy. It's x squared plus y squared under the square root. So R, it's the square root of x squared plus I squared, and that's why if you have a negative sign, you will get rid of it because of the square. Then we can calculate R. It's the length of that vector. It's 4.3 meter if you plug in the numbers for x and y. How about the angle theta? Okay, this is the trick. I'm going to totally forget about the negative signs. Any negative sign, I will totally forget about it. So I'm going to calculate tan theta, which is y over x. So it's 2.5 divided by 3.5. Of course, even if you put the negative signs in here, this will mislead you. And if you find tan theta, that's tan theta will equal to 0.714. If you have a calculator, find what is the inverse tan for 0.714. Inverse tan for 0.714 equals to
Why are you adding 108 to the angle?
I'm not, I did not add anything.
And we always say this right angle.
I did not add anything. I just said, just find the inverse tan for 0.714. 35? 65? 35, 36. For simplicity, I'm going to just, it's going to be 36 degrees. 36 degrees, there is no way that this angle theta can be 36 degrees. What did we really get? What did we really get in here? That 36 is this angle. Look at the graph. It's that angle. Between the negative x-axis and the vector. But if we need to find the angle theta, you should add to it 180. So the only way to do this, not to just use the calculator. The calculator will mislead you. It's obvious in here. Negative and negative will cancel out and it will give you the wrong answer. you have to draw the vector, like what I did. Then find that angle, sorry, then add 180 to it, right? Because we need to measure the angle from the positive x-axis till the vector. This is the way we define it.
No, we always, yeah, if I know it's the right angle and it's just 35 or 36.
No, this is the way we define it. We have to all to agree on one thing, that if we need to find your location, okay, I have to choose that as an origin, and this is x and this is y. Then I can describe your location. Okay. If I ask someone else to describe your location and he choose that as an origin, and this is x and this is y, he will give you a different position for you. So we have all, not only the class, but the whole community, they have to agree on a definition for the coordinate system. Okay? So we said to define the polar coordinate system, I'm going to use r as the length of the vector, and the angle theta should be measured from the positive x-axis going counterclockwise till the vector. This is a definition that we have agreed on. Can we change that? Of course we can change it, but as long as we change it, we have all to use it. Okay? So now if I ask you what is the angle theta, since we set the definition for r and theta, then you have to use that coordinate system, the way we describe it. If you want to change it, you have to write to me that your coordinate system is blah, blah, blah. It's the r, but the angle theta is measured from the positive y-axis counterclockwise, or the positive y-axis clockwise. You have to tell me how to measure it. Okay? Okay. Oh, yes.
No, what if it's in the fourth quadrant?
Mm-hmm.
And for example,
Perfect.
let's say it's going to be the answer is going to be negative, and it's going to be a negative angle,
Mm-hmm.
which means that it's going to. Do you subtract this from 360?
Let's do it. We'll do it. What else? Same thing? Okay. Let's do it. Let's assume that now the vector is in the second or the fourth quadrant, which is exactly the same thing. Oh, I mean the same way. Okay, guys, this is r, and we need to find that angle theta. That's the theta. Now, if you calculate, if that point is, I'm going to use the same numbers, 3.5 and negative 2.5. Am I right? X is positive and y is negative. Am I right? Okay, good. Let's calculate tan theta. It's going to be y over x minus 2.5 over 3.5. Theta equal to, I don't have a calculator.
Minus negative.
Okay.
Minus 3.5.
Minus 35. So I said tan theta equal to minus 2.5 divided by 3.5, and you guys have calculated theta to be minus 35.5. What is the angle theta? This is the angle theta. This is the angle I'm going to call it alpha, not theta. Alpha. Because that's theta. So this is the angle alpha. This is the 35 degrees that we're talking about, or the 36 degrees. What to do to find the angle theta? 360 minus that angle alpha, or gamma, whatever the name is. That's easy. Same thing in the second quadrant. Before I pick any more questions, let's do the second quadrant. Guys, that's where most of you make a mistake. Remember, I said in class now 3 times. you make a mistake in that part. And I will remind you after the first exam, I will show you some answers that they made the same exact mistake. Okay, guys?
In this example, why didn't we use cosine instead of tan?
You can use whatever you want. But tan, since you have y and x, you can directly get the tan theta. But in order to get cosine, you need to have r beforehand. Okay?
So we could get r by the rule of x squared plus y squared, right?
Say that again.
I said that we could get r by the rule of x squared plus y
Yes,
squared.
of course. Yes. So r equal to square root of x squared plus y squared. Of course. If we know x and y, we can get r and theta. Okay? But usually what I do is, your colleague here was saying, why do you use tan theta equal to y over x? Sometimes I make a mistake in calculating r. So if you make a mistake in calculating r and you try to find cosine theta equal to x over r, then you're going to carry that mistake in here as well. So it's easier to deal with that. But this is correct. This is correct. If you do this, you get 100%. If you do that, you get also 100%. There's no preferences in using any one on top of more than the other one. The second one, second quadrant. R, that's easy. Same thing. Tan theta will equal to, it's 3.5 divided by negative 2.5, and if you do the calculation, it will get you exactly the minus 36 degrees that you just got in the fourth quadrant. So you cannot distinguish between them if you just calculate it. You have to draw the vector. A minute ago, we got the same answer when we draw that vector in the fourth quadrant. We get minus theta, gamma will equal to 36 degrees, negative 36 degrees. And we got that same answer a minute ago. So if the vector in the second or the fourth quadrant, you cannot just distinguish between them by just using the calculator. You have to draw the vector, then look at the vector. We need that angle. This is the angle theta. But actually we calculated that angle.
Actually, it's negative 54.
Because I made a mistake. Okay, so thank you. So let's do that, 2, and that's 3. Okay, thank you. So you have to draw the vector. Look at the angle that you are calculating. This is the angle we are calculating, but we need that angle. So it's simply it's going to be 180 minus that gamma. Okay, good. Enough of that part. How can we distinguish between a scalar quantity and a vector quantity? In the book, yes. Yes, that's what we said in the arrow. You put on top of that vector an arrow. That means that this quantity is a vector quantity. But in the book, he will not use the arrow much. He will use a bold-face letters. No, bold-face letter. He will write it as bold. A, will write it, you'll find it as bold. Since we cannot do that on the paper or on the board, so we have to use the arrow. So arrow means that this is a vector, and we call that the arrow notation. Okay. Displacement. If I start from that point, and I go that way, I start from there, and I end up here. What is my displacement? That's the straight line. So that's my displacement. It has a magnitude and direction. So the displacement between any two points is just the straight line that connects between them. You start from point A, you end up at point B, then this is the vector quantity for the displacement between A and B, that black line in here. And it's independent of the way you choose to go through. It's independent of the path. It's mainly you connect a straight line between your starting point and your end point. Those vectors, those four vectors that you see now are equals. Why are they equal? Same length, same direction. Look, that's a vector A and that's a vector B. Hopefully if they are the same length, they have the same direction. This is the tip of the arrow. Those two vectors are equal. They have the same length, they have the same direction, they are equal. How about those two vectors? They are equal. How about those two vectors? How about those two vectors? They are not equal. Though they have the same length, thank you so much. Though they have the same length, but they are in different direction. So one of them has to be negative of the other one. This is A. We're going to call that negative A. Because it's totally in the opposite direction. Okay, guys? So those vectors are equal because they have the same direction, same magnitude. Can we add vectors? Can I add two vectors together? Yes, we have two ways to add vectors. The first one is graphically, and I'll teach you how to do it. Simply, that's how we do it. If you have a vector A and a vector B, and if you want to add them together, vector A and a vector B, and you want to add them together. So, draw vector A. From the tip of vector A, put the tail of vector B. Draw the tail of vector B. Then connect between the tail of A and the tip of B. That line that I'm drawing in the air now, that's A plus B. So you draw A. Of course, it has to be the same units. You draw B, you draw A, and from the tip of A, you draw B. You connect the tail of A to the tip of B, and that's vector R, which is A plus B. Okay, guys? And so this is vector A and vector B, and if we need to add them together. Now I have drawn to you two vectors, A and B. Can we add them together? They're not drawn right. But can we do this? Yes. A minute ago I told you if you have two parallel vectors, they are equal. I can move A, B in such a way to be parallel till it moves to the tip of A. That's what I did. Then I connect that line. That's A plus B. Can we do something different? Can we move A to here?
Yes.
And you get exactly the same vector. A plus B is equal to B plus A. Same thing. So if you move B or you move A, that line that connects between A, the tail of A and the tip of B, or the tail of B and the tip of A, it's exactly the same. That's A plus B. How about if you have many vectors? We follow the same principle. You get the vector R, which is in that case, it's A plus B plus C plus D. You add them, you draw each vector, the tail of each vector from the tip of the one before it, and you get the vector R, which is the addition of all those vectors.
But in this case, I have to have the R of each vector, right?
The length of each vector, of course.
Even sometimes I have
The length and the direction.
the X and Y, I don't have the length.
Yes. Then you have to convert it into, I forgot your name.
Nada.
Nada is saying, but if the vector is given to me in the Cartesian coordinate system, I should actually transform that into a polar coordinate system to get the length and the angle that it makes with the positive x-axis, so I would be able to draw it. Exactly.
That's if we're after,
That's one way to do it.
that's if we're after the graph.
Two graphical, but you can.
That's if you ask to do it graphically, or
Can't you just use the Cartesian coordinates?
or
You just cross it.
what's your name again?
Vanilla.
Farida is saying, well, this point that represent the vector A, which is going to be some x, 5, and 0, and that point I can just draw it and connect the vector 1, connect the vector 2, and 3, and so on, and I get the same exact answer. So if you convert it into polar, or you keep it in the Cartesian coordinate system, you should get the same results. Doesn't matter. Okay? But you don't have actually to convert it. But you can do that, yes. We said that A plus B equal to B plus A. I'm gonna, and if you have three vectors and if you add them together, so if you associate A plus B together, if you add A plus B together, then the resultant of that you add it to C. It's exactly if you add B and C together, then the resultant of that you adding to A, you get exactly the same answer again. Negative of a vector. What does a negative of a vector mean?
Direction.
Opposite in direction. And saying that will take us a little bit further, and can we subtract two vectors? Yes. Yes. Graphically, that's easy. I'll show you how to do it graphically. Yes, graphically. Can we subtract two vectors? Yes. If you have vector A and you have vector B, can we subtract them? Yes. Draw the negative of the vector B. This is B. This is going to be negative B. Now that line will be A plus negative B, which is A minus B. I'll do it on the board. Yes, I'll do it on the board. This is vector A, guys, and this is vector B, for example. Of course, this line is going to be A plus B. Do we all agree? Correct. Can we find A minus B? Yes. Simply, I'm going to draw negative B. How can we draw negative B? Same length. That's negative B. If it's the same length of B, but in opposite in direction, then this is negative B. Can we find A minus B? Yes. If we add this, this will represent to us A plus negative B, which is A minus B. Of course, do not forget to put the arrows. It's very important. Then we can do a subtraction graphically. Good. Is there any other way to do it? Can we actually add vectors or subtract vectors mathematically, not graphically? Yes. Give me coordinates of any two vectors. Just choose any two. A equal to 5 and 2. B equal to 7 and 4. Nada, right? She gave us those two vectors. I want to add them together. We add the x's together and we add the y's together. So we add those together. So vector R is going to be 7, 12, and 6. That's it. And if you draw it, you get exactly the same as the graphical method. Yes?
I was going to ask you to draw it.
Yeah, you get exactly, I'll leave that for you. Okay, because it's going to take a little bit of time in class, but it's very easy. Do it and show it to me next time. If you get the exact answer, graphically as mathematically, I don't need to see it. But if you get different answers, please come and see me. 12 and 6. Some people do it that way.
Transfer to the IMG.
Some people do it that way. And this is much, much better because it tells you which is which. Some people, sometimes they forget. They think that this is the y and this is the x. And they confuse numbers. So actually, mathematician came up with a way to resolve that problem. They said vector A is 5 units along the x-axis. And I'm going to distinguish the x-axis by letter I with a hat on top of it. I with a hat on top of it. We'll talk about that. What does that mean in a minute? But I means x-axis. 5 units along the x-axis plus 2 units along the y-axis. Ij. And if we have units along the z-axis, the z-axis, plus 0k. Because in that vector we don't have any units along any thing along the x-axis. Z is 0 in here. So plus 0k. So I means x, j means y, k means z. Yes. If it's 3D. And the vector b, can we do the same thing? It's 7 I plus 4 j plus 0k. Can we add them? 12 I plus 6j plus 0k. Can we find the magnitude of r? This is how we write it. R between two lines, that means that this is the length of r, the magnitude of r. Can we find it? It's going to be square root of 12 squared, x squared, plus y squared, plus z squared. Then we can find the magnitude of r.
What about the direction?
The direction, if you know x and y, you can find tangent of that angle theta. So that I, j, k notation has taught us something, that quantity is along x, that quantity is along y, and this is along z. What does the hat mean? The hat means this quantity here, it has a magnitude of 1. So 5 times 1, that's 5. Only 5 along x. So instead, sometimes we can write I vector. I vector or x vector. X vector will equal to x magnitude times I hat. I hat tell us the direction only, but it has a magnitude of 1. That's it. So that should not confuse you. So now, guys, in this room, this is the origin. This point is the origin. I want you guys to describe the location of that projector and write it down in x, y, z, in I, j, k notation. In I, j, k notation. Take a measure. Each tile represent half a meter. And make an estimate. You do not have to be you don't have to be accurate. Just do it.
This is the x and this is the y.
You tell me. This is the origin. And not the saying, well, we have to tell us also the complete coordinate system. So said, if this is x, this is y, and this is z, yes, okay. Can we change that? Yes, you can do whatever you want as long as you tell me what did you choose. X, y, and z. Now I want you to make an estimate of what is the position of that projector. 1 step is almost 1 meter. 1, 2, 3, 5. 5i. 1, 2, 3, 4. 4j and 4k. So we can write the location of the projector. The location of the projector, which is 5i plus 4j plus 4k.
So if we have, and if we get A and R, and we want B, we subtract
If you get what? R and A, and you know that A plus B equal to R, then of course yes, you subtract. Okay.
Do we have, will we be required to find the angle?
Oh well, that depends. If I ask you to find the position only, and I do not specify any coordinate system, then this is your coordinate system,
No, but
which is the Cartesian coordinate system. This is what I'm saying. We have 2 coordinate system. If I ask you to find the location of that projector, and if I don't specify any coordinate system, then you're free to do whatever you want.
but how do you find the angle?
Do we have to find an angle in the Cartesian coordinate system? Oh, then this is the problem in the assignment. Now we have a vector in 3 dimensions. We have a vector in 3 dimensions. This is the problem, the last one in the assignment about the vector, assignment number 2. Okay, guys? Can you find R? Can you find the length of that vector?
I squared plus J squared plus K squared.
Thank you. Nada again is saying, well, R, magnitude of R will equal to 5 squared plus 4 squared plus 4 squared under the square root. But how can we find the angle? How can we find the angle with the x-axis, the angle with the y?
It would be the same angle from here to here, the same angle from here to here. So it's tan
It's
y over x.
5 over the R value we get.
Which angle you get if you do this? If this is x,
If we do the 5, we get the angle with the x-axis.
perfect.
We get
Okay, I want to show you this. We still have time, right? 2 minutes. 2 minutes, right? Okay. Okay, guys, look at that vector. That vector has a projection on the x-axis, which is 5. This is the length of the shadow of the vector along the x-axis. 5 units. So this is 5, and you know R, and this is the perpendicular in here. Can you find that angle?
Which one? Between x and z?
Between x and R, R, I'm gonna just put R along the
Imagine each one as a 2-dimensional plane.
I'm gonna project R on the floor. So this is R. I'm gonna just lay it down on the floor. This is R now. That angle is the angle between X and R. Can we calculate it if you know X and R? Yes? Of course. Of course, yes. Cosine that angle equal to X over R. So if I know X and R, I can get cosine the angle, and if I know cosine the angle, I can get the angle itself. How about that angle? Phi. If you know Y and R,
The same thing, cosine thing. About y over x.
then Y over R equal to cosine of that angle phi, then I can get phi. Same thing for Z. The projection of that on the Z axis, it will give you the third angle. This is the problem that's in the last problem in the assignment. Before we go, I think I'm going to stop here. Escape. Okay, guys. So I want you to look at the calendar and communicate with me as soon as you can with any conflict we might get. We have agreed that we're going to have Saturdays at 9 o'clock. Inshallah. Yes, Saturday, this coming Saturday we have a class.
Are we going to have every Tuesday class?
No, specific Tuesdays. I'm going to put them today on the blackboard.
Thank you. When can I come to the last thing you did?
Yes, sure. Now if you want to, yes.